Oh, that steam just blew out. Oh. Okay, enough of that. Anyway, it's TC. That's my nickname. You know, I don't feel like saying my whole full government name. But today, I have another video for y'all. Told y'all to stay tuned. I wasn't wasting no time uploading these videos. Today I'm going to be explaining for heat pump systems, which is all electric, not gas furnaces, possibly even for dual fuel systems. No, I know for a fact it's for dual fuel systems. What exactly is a defrost cycle? What is the purpose of a defrost cycle? How often will I get a defrost cycle? What temperature does it have to be at for a defrost cycle to be activated? Let me see, what's another question that would typically come up on this topic? Let me see. Why does a fan not spin during a defrost cycle? Why does it make such a loud noise when the defrost cycle is activated and when it is coming out of defrost? Those are the questions, basic questions that I will answer in this video. Now, one major thing has to occur in order to basically cause a defrost cycle to be activated. Number one, the system has to be running in heat mode. Okay, it must be running in heat mode. Defrost cycles do not happen during cooling mode. That's almost, you know, second nature thought right there. A defrost cycle is not going to happen during cooling mode. Another thing, you know, it has to be a certain ambient temperature around those coils in order for a defrost cycle to occur. Because I can tell you right now, it can be, I'll just say, 40 degrees outside, 40, 43, and a defrost cycle can occur. How and why? Well, a heat pump or an air conditioner, it has to operate at a different temperature. Those cows are having a good time back there. Do you hear me? But anyway, they operate at a different temperature than their surrounding temperatures, if you know what I mean. And the reason for that is because during cooling mode, you are trying to reject the heat from outside in order to absorb heat inside and push it outside, or pump it outside, or condense it and blow it off outside, if you know what I mean. But in the wintertime, that's the opposite. You are trying to absorb heat and pump it inside. How does that work? Well, that can't work if you are operating at the exact same temperature as your ambient temperature. It's almost like, you know, it's kind of like taking a shower at the exact same temperature as your body. You won't really notice that much of a change. It doesn't feel hot, but it doesn't feel cold. It just feels at the same as you are. It's the same thing for a heat pump, you know, and typically they'll operate at about 8 to 20 degrees different than their ambient temperature. Now, I'll say an average is about 13 to maybe 20 degrees different than their ambient temperature. So in the wintertime, what is it doing? It is operating at about 10 to 20 degrees colder than its ambient temperature. In the summertime, it's going to be doing the opposite. It'll be operating at 10 to 20 degrees warmer than its ambient temperature. Now, when I say the seasons, I mean as if it were to be in cooling mode, and in the wintertime as if it were to be in heating mode. So the temperature of those coils can also determine when a defrost cycle will occur. It's typically between 27 and 32 degrees. Now, what controls the defrost cycle? Well, a defrost control board and a reversing valve. Okay, now what is a reversing valve? Let me just open this up. Boom, there it is. Okay, now it's a little different, which is not really different. It's just in a different position, a different spot. Most reversing valves will be sitting right in the middle, usually about where the compressor is. But for these ring units, they are going to be sitting in this compartment over to the left or right, whichever way it's facing the line set going in. So here is your reversing valve. Heck, I'll even show you on a different unit. Let me just run down here to this unit I got from my neighbors and show you a larger reversing valve for a 3-ton Weathertron XC1000 said to be high efficient unit. Here we go. It's the same thing. Reversing valve. Okay, that one's a little that. This is definitely R22. Back to the ring. Now, a reversing valve does nothing but control the flow of the refrigerant in the system. So I mean, it's, you know, reversing valves, they shift. They're either energized in heating or cooling mode. Now for reams, they default in a different mode than every other brand of units. You know, ream and Ruud, they default in a different setting than all other brands. Now when I say default, I mean when the reversing valve is not energized, that's what mode the unit goes into. When the reversing valve is energized, okay, it's either in or it's not in its default setting. Now, Reams and Ruud, Ruud, those units default in cooling mode. All other brands default in heat mode. So that means that even if I was to take the reversing valve on the low voltage side, if I take it out of circuit, it will still be in cooling mode. There's no power on that, so it wouldn't affect it. But when I got ready to go to heat mode, nothing would happen. It'd still be cooling. What a surprise. Like I said in my last video, the system is operating. It doesn't matter if it's operating in heat or cool mode. The compressor only spins one direction. The compressor doesn't really control whether or not the system is heating or cooling. It's all in control of the reversing valve. So I will put the system in heat mode. Now it clicked. When it clicked was it took the low voltage off of Y and G. Now it's flashing heat on. So in about 3 to 5 minutes, which for this one it's 5 minutes, the system will energize and the reversing valve will be energized in heating mode. Alright, so the system is now running in cool mode. Okay, our time delay is over with. Now we are running in cool mode. I'm sorry, heat mode. What in the world am I thinking? Alright. Maybe I need a reversing valve because I can't halfway think straight. But anyway, alright. So, defrost cycle. Obviously not going to happen on an 85-degree day, even if it is running in heat mode. I really feel like I had a clear explanation across when I explained the ambient temperature thing. So I'm going to go ahead and explain that, but I'm going to be in heating mode when I explain it. So even though it's summertime, the air coming out of the condenser fan will be operating colder than the ambient temperature. So I'm going to go ahead and flip this in heat mode. Like I said, for the ambient temperature, I'm going to get my temperature probe down here in my handy dandy little bag of tools. Bag of tools. There it is. Can I have a piece of the field? My HVAC jokes are terrible. Alright, I have my field piece thermometer. Alright, this is what I'm going to show you. Now, I'm going to turn it on. Go ahead and focus in on it. Focus. Alright, well actually it's about 87 degrees out here. Alright, now I'm going to go to the temperature of the air going inside the coils, which is about give or take about 85, 86. Alright, now for the temperature going out of the condenser fan. We see a drastic drop in that pretty quickly. So like I said, in order for it to absorb heat, it has to be operating a little bit colder than the temperature of the air around it. Okay? So we went in at about, we've already passed our 10-degree mark. We said about 86 going in. We've got about, let's see. We got about, we'll say about 69 degrees, 69, 70. Okay, now it really is getting close to 60. I'm going to go ahead and bypass the time delay on the thermostat. This is only to be done by a qualified technician. Please don't go trying and digging your fingers and things at home. I shall not be held responsible for any risk of electric shocks by anyone doing irresponsible things. I'm going to go ahead and put that disclaimer out there. If you have any questions, please ask your technician. Please do not go digging your fingers okay, because a lot of times y'all may not be able to discern between high and low voltage. Like I said, I am not held responsible for any mishaps by that of a non-qualified technician.
Flip the switch and put it in cooling mode, bypassing the thermostat. Now we will see the ambient temperature difference when it is in cooling mode. So you see that? You see it's already going up just that fast. So the temperature going in, we'll just go ahead and say it's still at about 80. I'll say give or take 84, 86. What's the temperature coming out? See, we're getting up there. We are getting up there.
While we wait for that to kind of read the temperature and, you know, pick up the temperature of the air coming out, it's currently in the stage of rejecting heat. Okay, it's rejecting. Look, I'm gonna tell you something. If I had to fight that wasp, but it is rejecting heat from outside because it's trying to push heat from inside outside. It can't do that if it's operating at the exact same temperature as its temperature outside. So it has to kind of reject the outside heat in order to push more heat out. If that makes sense.
Right now we're coming out at about 96, possibly 97, maybe even 98. Now the reason I'm saying ahead is because I see it climbing pretty drastically. So just kind of keep that in mind. We may even be pushing about 99. I'll just go ahead and press hold right there. So that's basically the temperature that we're coming out. So we started at about 85, 86 degrees. We're coming out at 98. So 98 minus the temperature that was going in, or its ambient temperature. 98 minus 85. We'll just say that's probably about 11. Sorry, that's more like about 13.6 degrees.
That details the same thing even if it's 20 degrees outside. Yes, a heat pump can, and it will, absorb heat from 20 degrees outside. Now you will see a whole lot more frequent defrost cycles, and it may not be the most pleasant thing, but you know, in order for it to operate like it's supposed to and be a pump, a heat pump, it must get that ice off of it. Now how in the world does it get ice on it at 40 degrees? Like I said, it will operate at a colder temperature than its ambient temperature. Another thing you will see during the defrost cycle is you will see the coils, you know, before the defrost cycle, they'll be kind of white, a little bit frosted. They may even have a sheet of ice on it. But when the ice starts to get hard and it's not going to defrost cycle, you need to have your system service. It's good to have your system service regularly. Dang mosquito. But another thing you will see, like I said, the fan will be off. Okay, but the compressor will still be running, and you will hear a swooshing noise like that of a pressure release, or like that of a valve of high pressure opening. But that's really not what's going on. It's just it's rushing this way, or now all of a sudden it wants to go this way. You know, it's rushing one way, now all of a sudden it wants to go the other way. Like I said, it's like going 80 down the interstate and then slamming it in reverse and flooring it. For this particular system, it doesn't go straight from one mode to the other. For this particular ream system, or maybe even more ream systems, it will shut the compressor off and the fan off, give it a second, and then the reversing valve will be energized, and then the compressor will come back on. Now that's another protective feature right there. And you know, that's a different type of shift right there.
Since I can't force it to go into defrost mode, I'll put a clip in of it actually being in defrost mode back on my back in wintertime when I caught it in defrost mode on like a 28 or 30 degree day, and then when I got it to force the defrost on a day where it was probably about 60 degrees and it was probably operating at about 40 degrees. So I'm gonna go ahead and put this back together. Here we go. That's the noise that you will hear. Let me take this camera off for a second so I can actually wire nut this back together.
This video is going to be a little bit longer than that last one because there's a little bit more going on than just a simple operation of a thermostat. This is actually all being controlled with the thermostat, with the air handler, and with the outdoor unit. Now, another aspect of the defrost cycle is understanding that it's not just shifting, it's shifting from one mode that it's been set in to another. So it's in heat mode, but it's shifting itself into cooling mode, because in heating mode it's reversing itself. It's trying to pull any means of coldness to a certain level that thermostat been set. It's trying to extract cold from inside and pump it outside, but it's also cold outside, so it can cause ice. So when it goes into defrost mode, it's shifting itself out of heat mode into cooling mode. All right, now it is indeed going to be pumping cold, or not pumping, but it will be pumping cold refrigerant inside. Okay, but the question that you have now, your question now becomes, okay, I'm trying to heat my house. Why is there cold air coming out of my vents when it's in heat mode? Somebody need to come fix this. Pick up the phone. We need to call the technician. Calm yourself, okay? Calm down. All right. This has been thought through. When it goes into defrost mode, there is a signal, a low voltage signal for us technicians that are, we speak the same language. It's a low voltage signal being sent back inside to the air handler to energize the heat strips. Okay, the heat strips get energized when it's in defrost cycle. It's the auxiliary heat, the emergency heat. It all operates the same. Okay, it's going to have auxiliary heat is what will usually pop up on the thermostat when it gets that signal. That's how you know it's in defrost mode, or when it can't keep up, when the system can't extract enough heat outside, it will to pump inside, and actually, in order to actually change the temperature, or in order for it to reach the temperature that you set it at, it will energize those heat strips in the auxiliary heat mode. Now, what you don't want to do is have emergency heat on unless it is actually an emergency. Okay, now those heat strips get energized during defrost cycle, and it's meant to overcome the defrost cycle. Okay, your air coming out of the vents will possibly range between, I'll say it'll range between 75 and at max 95 to 100 degrees when it's overcoming that defrost cycle. Now, when it's doing its heat pump thing without the heat strips, it may be 105, 110, 115 degrees alone. Maybe on a 40-degree day, but when the heat strips are energized, you're gonna have air coming out those vents pretty dang warm. It won't be warm, it'll be hot. Okay, it may come out at about 115 to 130 degrees when it's all working together. All right. So that's just my explanation and breakdown of what is going on during a defrost cycle. How often will I get a defrost cycle? And another question I forgot to answer is, or another thing I forgot to pinpoint is steam. Okay, it's steam, not smoke. When you see moisture rising out of that heat pump, even when the fan's not on, that's basically that ice. It's evaporating. It's being heated very, very quickly. Okay, it's being heated. And it's, in order to melt ice, you got to add some heat to it. Ice is an insulator. It can't extract heat when it's being blocked by ice. Okay, or it can't pull heat when it's being blocked by ice. So that ice gets heated very quickly. It'll either rise up or flow down, and you see water pouring off the outdoor unit and steam rising up. That's what you will see. And it will even blow out, for maybe 5 or 10 seconds after it's came out of defrost cycle. So that's the breakdown of what a defrost cycle is, how it operates, why it operates, how often will it operate. And another thing, I just keep thinking about it. I'll actually show it to you. 30, 60, and 90 are the most common numbers that you will see for a defrost cycle timer. I'm trying to see exactly what ours is set on. I think ours are going to be set on about 60. But yeah, that's the defrost cycle. So even if it has not required itself to have a defrost cycle, it's going to go by that timer. So if the system has been running continuously for 30, 60, and or 90 minutes, really, or not and, it will go into defrost mode. If it's been that long and it hasn't been a defrost cycle, it will go into defrost mode. That's my little breakdown video of what exactly a defrost cycle is, how it operates, what triggers it, what causes it, what are the conditions that have to be going on for it to be triggered. And so I would like for y'all to, stay tuned. Keep a watch on my channel, because I'm revamping my channel up here. Yeah, that's just kind of the gist of what's going on. Now, not only am I trying to revamp my channel, I'm trying to help people understand or get a general idea of how these things work and the thought process and ingenuity that goes into these things, you know, an understanding will prevent a misunderstanding. When we all understand things, we can actually relate to each other on a better level than just being clueless out the blue. So, stay tuned. Keep watching my channel. Share this video for people who have heat pumps or are transitioning from gas to heat. You know what? I might as well just make that a video. I've got so many videos to make. It just keeps coming in my head. Heck, my next video is going to be how often should I have my condenser cleaned, because that one down there looked mighty dirty. In fact, I filmed it on purpose while it was dirty so that I can show you that even the dirt that you can't see on the outside, there is dirt on the inside of that condenser, and that condenser cannot breathe and operate and properly condense if it is not, you know, if it can't breathe and if it's not clean. So y'all stay tuned and like, subscribe, and please do share.